Hello everybody, I'm Sia. Thank you so much for watching my videos. So today what are we going to do is we are going to continue with our chapter Electricity Part 4. So now I'm going to ask you some questions and you have to tell me that do you know the answer of these questions in the comment section, and if you don't know the answer of these questions then my friend you need to watch this video. So the first question that I'm going to ask you is, what is resistivity? And do you know its derivation, that how the resistivity or the formula of resistivity is obtained? Then, what is the difference between resistance and resistivity? Why is tungsten used almost exclusively for filaments of electric lamps? Why are the conductors of heating devices such as irons, toasters, etc., made of an alloy rather than a pure metal? So, first of all, let's start with resistivity. Let's know about resistivity. So, from the first equation, that is R is directly proportional to N, we can say that resistance is directly proportional to length of the given wire. So, that means that if the resistance will increase, then the length of the given wire will also increase, and if the length will increase of the given wire, then the resistance will also increase. And from the second equation we can conclude that R, that is resistance, is directly proportional to area. So from both these equations we can write that R is directly proportional to L upon A, that is length upon area of cross section of the wire. So I have already told you that whenever the sign of proportionality is changed into equal to sign, then always it's a necessity, then always a constant will be added, and here the constant is rho, which is denoted by P. So the constant here is rho, and this constant is known as resistivity, and this is denoted by P. Hope you all have understood that what is resistivity. Moving ahead, SI unit of resistivity is ohm meters, whereas the SI unit of resistance is ohm. Okay, so the next point is resistivity depends on temperature and material of object. Then resistivity of an alloy is generally higher than that of its constituent metals. Now we know that what is the SI unit of resistivity, it's ohm meters. Then moving on to the next point, what does it say? That resistivity depends on temperature and material of object. For example, if we have a given wire, for example we have a copper wire, fine. So if this is a copper wire, then its resistivity for the given length, for the given area of cross section, will always be same. For example, the length of copper wire is 5 meter, fine. And if we take, and then we take 10 uh, meter wire, then its resistivity will be same as of 5 meter wire. So I hope that you all have understood this point. So resistivity does not depends on area of cross section of wire and the length of wire. It depends only on material of object and on the temperature in which it is kept. Moving ahead onto the next point, that is resistivity of an alloy is generally higher than that of its constituent metals. This point simply means that the pure metals have lower resistivity than alloys. So alloys resistivity is higher than that of its constituent metals, that is pure metals. Moving ahead, now what is the difference between resistance and resistivity? In the definition or in the first point of this difference, you just have to rote it. That is, you have to do its rote learning. And the first point is the property of the conductor. What is resistance? It is the property of a conductor due to which it opposes a flow of current through it and is called resistance. Now what is resistivity? The resistivity of a conductor is the resistance of a conductor of unit length and unit area of cross section. Then the SI unit of resistance is ohm and the SI unit of resistivity is ohm meter. Then the third point of the difference is the resistance of a conductor depends on its length and area of cross section, whereas The resistivity of a conductor does not depend on its length and area of cross section, because resistivity depends on material of object and the temperature. Moving ahead to some reasoning questions. So from this topic, only two reasoning questions can be formed, and the first is, why is tungsten used almost exclusively for filaments of electric lamps? That why is tungsten only used for filaments, for making filaments? Why isn't other metals used like copper, silver, gold? So the reason is, tungsten metal is used exclusively for making the filament of electric bulbs because it has a very high melting point. So first point is, tungsten has a very high melting point. Due to its high melting point, the tungsten filament can be kept really very hot, that is white hot, without melting away. So we know that for making a filament we require a metal which has a very high melting point, and tungsten fulfill this trait. Fine. So, and due to this high melting point, due to its high melting point, the tungsten filament can be kept white hot, that is really very hot, without melting away. So the next question is, why are the conductors of heating devices such as irons, toasters, etc. made of an alloy rather than pure metal? So the question says that why the heating devices, जैसे कि हमारे iron is our press from which we press our clothes, and the toasters, bread toasters, obviously, why they are made of an alloy rather than a pure metal? So the first point of this answer is, alloys have high melting point and hence they can be kept hot without melting. Second point is, alloys have higher resistivity than pure metals. That this second point I have already told you, that alloys have higher resistivity than pure metals. And please pardon me for this question 5. It's not question 5, it's question 2. So sorry for that. So that's all for this video, and if you haven't understood anything, then please comment down below. I'll try to resolve every question. Please stay tuned until my next video, and for now, bye.